Welcome to the ML Dropout. In this video, we'll cover how to load data into Pandas, and then how to do some basic exploration of that data and some basic manipulation of that data. So in this video, what we're going to cover is what is a data frame versus what is a series, how to read a CSV file, an Excel file, a TSV file, some basic EDA. We're going to deep dive into what is a Pandas series, and then there is some bare bones plotting that we'll do for EDA as well. So first, we're going to import pandas as PD. That's just kind of the general standard when working with pandas in Python. Everyone in the world imports pandas as PD. So we'll go ahead and click on that, Shift Enter to run. Now we'll come down here. We're going to load a CSV file into a data frame. And a typical naming culture for naming your data frames is typically to use DF. DF is in data frame. So oftentimes, if you see in my videos, you'll probably see like DF underscore something. And that just basically says like this variable is a data frame, and then I give it some kind of a additional tag to say what the data frame is. So here's just a data frame with the CSV data. So we're going to be loading some CSV data that has obesity, population obesity percentages by state. And this is kind of old data. I think it's like 5 or 6 years old. I got it off the internet, but we're going to read it. And then what's going to happen is we're going to look at the top 3 rows. That's what this head does. So the data is loaded. We can now see what is in our data. So we have this object ID column. We have this name. Name is going to be your state. We have the obesity percentage, the shape area and shape length. This gets into basically like the state itself and it's kind of its shape. We don't really care about that, but maybe if you were like a GIS analyst, you would. Now we'll go down and we'll do the same thing with Excel. So in Pandas, if we want to read a CSV, we do read underscore CSV. If we want to read Excel, it's read underscore Excel. And then obviously you have to include what is the file type. So do that. We see it's the same data. Now another common data type that you might come into contact with is a TSV file. There's also Parquet files. We won't cover those. A TSV file is tab separated values. So you think about CSV, it's comma separated. TSV, it's just tab separated. Shift Enter will run it. Again, we see the same information. So now let's just assume that we did have a use case for loading 2 different types of data or tabular data, as in like 2 different file types, and we wanted to know if they were the same. We could easily come down here and say df underscore CSV equals df underscore TSV. And what this is just going to do is it's going to go through all of the columns and all of the rows in the data set or the data frame, and it's going to compare to see if they are the same. So here we get the output. In the most cases, we're going to see true. We do see false here in this row 41. The reason for this is likely because of null values, or what we might call like NaN values, but we'll get into that later. So exit that. We have the data loaded. We've compared it. It's the same. Now let's get into some of the basic functions that we're going to use for exploratory data analysis, otherwise known as EDA. So the first function is going to be this head. We saw this earlier when we did head 3. The parameter we passed in was 3 to say that we wanted the first 3 rows. By default, head will give you the first 5 rows. If you want, you can say head 10. It'll give you the first 10 rows, but it's always going to start from the top of your tabular data. So head will give you the top of your tabular data. Likewise, you can do .tail. .tail will give you the bottom of your tabular data. Now, what if I want somewhere in the middle of my tabular data? You could easily go df underscore CSV and then put these brackets here. And if you know what the length of your data frame is, so we know it's 51, you could come in here and say like, I want to see 20 to 30. And this will show us somewhere in the middle of our data frame. Another way to do this could be with .sample. This will give us some random records. I could say sample 5, give me 5 random records of my data frame. So these are just different ways that you can say, okay, what is the structure of my data? I see the columns, right, the headers. And then I can say, okay, what is the contents? This will give me an idea of like the type of values that I'll see in there. Now let's get into csv.info. What this is going to do is it's going to tell us if there's null values, the data type. In some cases, this is really useful. In some cases, it's not. In this case, I think the main thing to know is like, okay, we have 3 different data types. Object is typically going to be string. So we have integer, 3 floats, and we have a string. And then it tells us what those data types are. and then it tells us like the range of the data frame and how much memory it uses. This is not the most accurate memory. I would highly recommend you go read on Stack Overflow about this because it's a wormhole. But just know, like, don't take that as the source truth when you look at the memory. Now we'll get into describe. This is going to be more like your summary statistics. It's going to give you the count of values in each of these columns. So as we see, the count in shape area and shape length is one less than OBC and object ID. And again, that's likely because of null values. And actually that would be, if your count is one less, it's because you have a null value. We're going to get the mean, the standard deviation, the min, the 25th, 50th, and 75th percentile, and then your max values in your CSV. Now let's get into value counts. What this is going to do is it's just going to give us a numerical value to the right of each of these rows. And essentially what it's telling us is how many times this distinct group of values appears in our data frame. So if you are familiar with like a group by function in SQL, or maybe doing like a pivot table in Excel, what we could say here is that all of these are rows of our column, right? So the number of times that this exact same set of values appears together is 1. If I were to come in here and add a row to my data frame that copied this value would be 2. And we will actually go ahead and hide this so that it doesn't annoy us. Now another one we have is this n unique. N unique is just going to tell us the number of unique values in each of our columns. So if you have worked in SQL, SQL has like distinct, so you could do like count distinct star in SQL. Here you can just do n unique. We also have is null. So this will just tell us where is a null value. Okay, we see that it's true in this row 41. You have is NA, which is kind of the same thing. Again, we have true on this row 41. You have columns. This will just give you what are the columns of your data frame. This is particularly helpful when you're doing data wrangling because you may want to use this in some kind of a function, or you may want to get the column index values. And if you really wanted to use this in some capacity, you don't want to use it as index, so you do something like casting this to a list, and then now you just have the values themselves in a list, and you could assign that to a variable, right? So I could just say like calls equals that. And now if I were to do calls, we have our values, right? So that covers more or less your basic exploratory functions when we're just looking at a data frame. So now what we're going to do, coming back to the top, we're going to look at what is the difference between a data frame and a series. So I put 2D and 1D here. So a data frame is going to be this tabular data set. A series is just going to be a column in this tabular data set. So it could be name, it could be obesity, shape area, whatever. It is going to be a one-dimensional array of values. And when you have a Pandas series, you're typically taking it from a Pandas data frame. So here, the series that we're going to get into is we're just going to do obesity. So the way you access it, there's 2 different ways to do it, actually. You could go obesity doing just like a period obesity. And I did not put the underscore there. I'm sorry. And this will give us those values as a Pandas series. And you can kind of see like, okay, it tells us the date type, tells us the name of the column, blah, blah. The other alternative is you can put it inside of these square brackets. Again, same values. And similarly to what we saw earlier, if you wanted to, you could convert this to a list. There really isn't a good reason to do that, but you can since we're here. So now that we can say, okay, I have this Pandas series, why would I want to just access this series? Well, one thing we could do is we could say .unique. So what this does is it's going to show us what are all the unique values inside of this series. You could do is NA, and it would just show you within that what are all of the NA values. You could do N unique and get the unique number of counts per the series. So a lot of the things that we saw above, they are applicable to a series as well. Another thing that you can do with a series is you can plot the series. So Pandas by itself can offer some of that plotting capability. So if I just add this dot plot to any Pandas series, it's going to give me this line plot. Now, in the context of the data that we have, this isn't particularly useful, right? Because these are all distinct states. We're not looking at values over time. This is not time series. So maybe what we want is like a histogram. So we can even say, okay, what kind of a plot do we want? I can say how many bins I want. And now we get more of this distribution, which is more relevant in the context of our data. So now, lastly, what we want to touch on is a little bit of data manipulation, right? So if we look at this DF CSV again, and if you just do the data frame by itself, it'll show you either the full data frame, depending on how big it is, or it'll show you like the first 5 and the last 5 rows. So now what we're going to do is we're going to manipulate this a little bit. And let's just say like, I don't really care about these shape area columns, right? So maybe the first manipulation I want to do is I want to filter down the columns that I'm using. So a way that I could do this is, again, going to what we looked at above. I can do df underscore csv dot columns, and then I'll do to list, right? And we'll have calls equal that. And then what I'll do is df underscore csv equals df underscore csv. And then inside of square brackets, I will give it this list, okay? What this is doing is it's telling it, I only care about these columns, and we're assigning that over itself. So we're basically saying the data frame now is only the columns that I care about. Now, does this change anything? It does not, because we haven't filtered down those columns. But what we can do is in this call, or I should name it calls, that makes more sense. We could say calls equals calls minus 2. Okay. And what calls minus 2 will do is it's going to cut out the last 2 values of that list, right? So it's going to give us the first value all the way to the third most last value. So by not putting anything here, it says, okay, we know we want everything that the list starts with, and by putting this here, we say we know we don't want the last 2 values. So now this is what our calls is. So we can run that same operation, and I need to put the S here. And now we have filtered down our data frame to only contain the information that we want. Okay. Now let's say that we have this. What if I want to sort it into a context that makes more sense? So what I can do then is I can go sort values. And now I'm going to put the column name that I want to sort by. This is going to be obesity. And we're going to do ascending equals false. And then what we'll do is in place equals true. So what this says is to sort the values and then overwrite it on the existing data frame. And then the ascending equals false means we want to see the highest values first. So now if I come here and I look at it, we'll see all of these states rank ordered by their obesity, right? And so now this is a little bit more useful. And I think for this video, this is where we will probably stop. If you are interested in getting a more in-depth tutorial on how to wrangle data, how to clean data, how to maybe apply functions to data, definitely drop some comments below. It's something that I've debated whether I want to do or not, but if you found this interesting and you would like to continue learning more about this, then let me know and I can make more videos. Thank you.